Okay, so we are going to record this. This is related to the new science curriculum, so the new revised version, but we just want to tell everybody that has been with us for this year already that the sessions that we had done prior to this will stay up and posted, but you need to maybe also tell colleagues in your school that might be using them that if they're going to download any of those resources, that they have to double check against the new numbered outcomes or the new curriculum document, because it has drastically changed. And so you cannot just assume that you can grab all of the previous sessions and it's just a perfect match. We are going to redo these. We are going to leave those up, but we are going to significantly change the format, and we'll talk a little bit more about that at the end. But just to reflect maybe things that we learned along the way as well, and just other ways that we can incorporate some of the pieces that haven't been done right now, just in the essence of time, and that we haven't sort of been able to find enough time to get through it. Don't know how we're going to find all the time, but we're going to do the best we can. So again, we're unpacking this from my perspective. A lot of what I'm giving you is going to be just surface level. It's just information. So you have a starting place to start grabbing some. And Ted's going to do that fantastic job of tying your concepts together for you so that we can start drawing that. And then when we redo them again, we're going to add in some other components to this as well. So welcome aboard again. So we are going to begin our acknowledgement with a very small sort of section from Wilfred Buck, who is considered an expert in the Indigenous star language and understandings. And he is actually going to be coming again back to Alberta. He's been here quite a bit, but he's going to come back again to Alberta in the fall. And we actually are going to bring him to the HESI Observatory, and that's where we're going to try and link some of the science 4, 5, and 6 for the new curriculum, as well as the Indigenous worldview of stars at the same time. So we're just going to start with a really short view or video from him, and then we'll go to our acknowledgement.
Dansen doet hem nou ook. Wilfred Buck is de sneeuwassen. Opaskwayak die know it. Greetings, my relatives. My name is Wilfred Buck from Opaskwayak Cree Nation, and I'm going to be relating to you some stories about Achagosak, the stars. One of the first things people should understand about the sky is that every culture on the face of the earth had the connections to the sky, because everybody lived under those stars. And prior to the Industrial Revolution, they lived under those skies 24/7. They lived under the skies. There was no light pollution to interfere with their view of the night sky. And so when it was clear, they could see awesomeness. And so our people had connections. The Inyo, our people, the Cree people, we had all kinds of stories about the sky. And a lot of them talk about our worldview. A lot of them talk about our philosophy. A lot of them talk about our understanding with reality, our understanding with the universe, and our connections to everything.
Okay, let's get back up. So with our acknowledgement in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to the original peoples and the story of creation of this country in a way that history may have forgotten. So as we were mentioning to start with, we are going to be making a few changes as we go into the newer session, but we will still file this particular portion in the pilot. So when you go to the files, you're going to see a pilot folder and you're going to see an implementation folder, because now you're moving forward with the approved curriculum and all the changes that have been made. So just so that you know the differences, that'll be really important. And I'm going to turn it over to my awesome colleague, Ted, and he's going to take it away from here.
Thanks, Chris. Welcome, everyone. Yeah, this being the last of the sessions, and I'm not too sure how many of you will continue on and with the implementation next year, but we hope that this session will help build some of that confidence and give you a sense of direction and that sense of efficacy that you've got this. Not only for this organizing idea, but like I mentioned, if you continue on and do some implementation next year. As Chris mentioned, we're going to change it up a little bit. This front-end stuff is something maybe you've heard me talk about before. I'm going to try to change it up a little bit so it's not too repetitive and provide some examples more specific to this organizing idea. But it's going to be this front end that we're going to, record in a session 1 so that we'll have more room in our sessions to provide more hands-on learning examples and focus on some other things other than this front end part. So anyway, we'll continue on. We'll have a similar agenda to last time where we will take a closer look at the cusps, how knowledge, understanding and skill and procedures work together to create those big ideas. We'll look at some instructional considerations along the way in terms of how they relate to surface, deep, and transfer learning, and a brief look at some assessment ideas. And then Chris will once again share with you a whole lot of wonderful examples that will fit within that framework. So I always look forward to that. Organizing idea once again is space. It's that whole connection that the living world, the earth are all interconnected along with everything else under the sky. And we investigate how those natural systems interact with each other, including us. So when we do take a look at all the organizing ideas, we'll know that from K to 3, there is no space organizing idea, and there hasn't been space in grades 4 or 5 either until I think it used to come up in grade 6. So this is new to the grade 5 teachers as well. And you can see it show up there. But like the other organizing ideas, things taught and learned at grade 4 move up into grade 5 and move up into grade 6 as well. So things like objects in the sky, as well as things about moon and constellation and stars, those are all examined in grade 4. And knowledge of those understandings become useful when looking at the cusps and the learning outcome for grade 5. Once again, when we look at the big picture here, what we do want at the end of the day is the students to walk away from our classrooms so they are successful in the next year's science course. So it's that sense of transferring those ideas and understanding so they can get them to a transfer level so they can carry it with them to the next grade. We also know we want students to come away with attitudes and skills that will help them and understandings that will be with them when they leave not only our classrooms, but our schools and graduate from high school. So keeping that in mind, that transfer is our collective goal, we're going to approach and unpack this curriculum through that lens of how do we get kids to transfer the important thing in this curriculum. And what we'll find here is that when we look at the cusps, the knowledge, the understanding, and the skills and procedures, there are things in all those 3 columns that transfer. So we'll unpack each one slowly and then take a look at how we can work at transferring knowledge, understanding, and skills. Just by brief example, what I mean by transfer, we look at skills, for example, we know that we can use a skill in a variety of contexts. So if we take a look at collaboration, we don't just use it in the classroom. We hope the students would, when they're young adults, would use it outside the classroom, when they're in university and all over, or when they're on the playground, when they're working not only in science, but when they're working in social studies and other classrooms. So skills and procedures transfer. The individual concepts that students learn also transfer. I've used some examples, some fairly abstract examples here concepts here, because the more abstract the concept, the greater the transferability. But something like courage and independence, those are concepts. And you could see perhaps each of them in each of those photos. In image 1, you might be able to see courage and independence with that plant growing there. Courage and independence may also be evident in that young boy standing on top of the ladder above the water. And finally, the understandings, that center column, do transfer. So if we take an understanding such as poverty exists across cultures, we can look at a variety of contexts and make sense of that context, or make sense of that context through that understanding, and realize that poverty does exist across cultures, place, and time, and so on. So keeping in mind that all those things transfer, let's focus on the sort of the nugget of the whole thing, and that's the idea of a concept. And the concept is simply an organizing idea of 1 or 2 words. The top 2 photos show a picture of a book, and the bottom 2 photos show images of magazines. While they're similar, they're both distinct concepts. We would automatically distinguish between a magazine and a book because they do have certain attributes that make them so. And so a concept is a thing that's describable in 1 of 2 words that has certain attributes, and there are multiple examples across different contexts. We can see those 2 happening there in that photo. Concepts do range from being very general to quite specific. Outer space and space is a quite broad concept, but we can narrow that down to space travel or space objects. We can narrow space objects down to stars, planets, and so on. The broader the concept, the more transferability it has. The more specific the concept, the less transferability. It becomes more rooted in knowledge and fact, but it allows students to go deeper and deeper into the discipline that they're studying at the time. And concepts are useful to provide a focus. So we take individual concepts and we look at this image through the lens, perhaps, or of the concept perspective. We focus on certain things. We focus on the road and how it disappears into the distance. But if I asked you to look at through the lens of climate, you would notice some other thing. We could see that there may be even a little bit looks fairly warm and tropical. We see that there is some snow in the mountains there. And what does that say about climate? What is this? We see change happening in this photograph. So depending on, that's where concepts, the transferability of concepts does help provide focus for different things. So we'll just keep that in mind, because that's what we're going to do next, is look at the cusps through certain conceptual lenses. And the conceptual lens we're going to begin with is the conceptual lens of a concept. Let's take a look at our organizing idea and the concepts within it. As we know, this is the way our curriculum is written, with the guiding questions, learning outcomes, and the cusps. And if you look at them carefully, you'll find that there are certain concepts. You can point them out. And as you look closely, you'll see that some concepts seem to be more repetitive than others. And that gives you an idea of some of the key or big concepts that this unit is working on. You can go to the next slide, Chris. I've highlighted them for you. We can see astronomical phenomena, observations, interpretations show up often. And there's some other minor ones that do show up, but as the more you look through the organizing idea and look at all the cusps, you'll see that there is quite a repetition of a few of them. And the ones that I picked out as the anchoring ones are the ones that are most important for this organizing idea follow on the next slide. Really, we're looking at different astrological phenomena. I think there's 6 examples that this organizing idea is looking at. But they all fall under that big idea of astronomical phenomena, and then how cultures' observations and interpretations of those phenomena change daily life, and daily life should be in there. We also know that those astronomical phenomena often occur in cycles and patterns, and that they can be represented as well. So when we take a look at the cusps, it's the knowledge column that does provide us with a lot of the information about those individual concepts. They're often defined. As I mentioned, concepts have definitions, and the definition of a lot of those concepts are here. Here we see that astronomical phenomena is defined, but other ones are not. For example, predictable pattern cycle, it's not defined in here, and neither of those are defined anywhere in the science curriculum. So we may have to go to math or some other resources to find a good working definition for students to use with patterns and cycles. And you'll see that happening throughout, but quite often the key concepts are defined in the knowledge column. But we know that concepts have more than just definitions, they have examples. And so in this case, we have astronomical phenomena examples are provided in there. And if there are no examples, they'll have to be generated. I think in most cases, things have a lot of examples in this one. Of course, the whole entire organizing idea revolves around those key astronomical phenomena there. And if you look at the left-hand column, you'll see that there's a lot of definitions about seasons and moon phases and eclipses and so on there. So a lot of it's directly related to this, this line right here. And we take all those ideas that are not only in the understanding and the learning outcome, but we can pull some out of the the more minor concepts out of the knowledge side. We can create a concept map that gives a fairly good idea of what the course looks like. I use the word phenomena at the top as the main column because there are different phenomena in science, and the one that's focusing in this organizing idea is astronomical phenomena. And you can see it's organized to all those different examples that we already looked at briefly in the knowledge column, from seasons, moon phases, solstices, equinoxes, and so on. Those are all examples of astronomical phenomena. And we know that some of the astronomical phenomena can be represented through different things, calendars, different cycles, and so on. And that astronomicals are observed and then interpreted, and then we get an application in our lives. There's a section that takes a look at the First Nations and understanding and an application of astronomical phenomena in their lives. And we can even examine some of the things in our world, such as planting and harvesting and hunting and so on. So it gives you a broad idea of what the organizing idea looks like. Let's choose a different lens. Let's take a look at understandings. Understandings are really groups of concepts stated in some kind of a relationship. So if we were to pull out, if we were to focus on the left side and those four concepts, observations, interpretations, daily living, astronomical phenomena, they're for the most part in the knowledge thing, and each have their own separate meaning. Students know what an observation is and what an interpretation is. They should know before we move on what daily living is all about, and certainly the focus is on different astronomical phenomena. But if we were to ask to put those four words into a statement, we would get a couple different meanings depending on how we organize them. My first organizing or thought looks at the one on top here. Our daily living can affect the interpretations of our observations of astronomical phenomena. Daily living should be highlighted. Now, how we live and the culture we live in can sometimes affect our interpretations of the observations we make, or observations and interpretations of astronomical phenomena can inform our daily living. The opposite kind of could be true. There's two different understandings, same concepts, and it's that bottom understanding that this course focuses on, or this organizing idea focuses on. So we can go to the next slide. And we see it there. It's the only understanding in this organizing idea, but you'll see that a lot of the individual concepts are under that whole umbrella of astronomical phenomena. That's really then the focus of this unit, and you can see it's quite reflective in the outcome as well. And so what we want to be able to do is students to demonstrate that understanding, that different observations and interpretations of these things, of the astronomical phenomena, do inform daily life in some way, whether it's our culture or other cultures, past, present. Those are understandings. Understandings themselves are transferable. So when we take a look at the understanding of this, the only understanding in this organizing idea, we can ask ourselves, is that understanding true in both these contexts? In other words, can the cyclical patterns of seasons inform what we do? Can the cyclical patterns of seasons inform what we wear? And so we could see that that understanding is true in both of those contexts. And that is, again, another example of how understandings can transfer from one context to the next. So before I go on to the next thing, I just wanted just a real brief summary here, because we've talked about concepts, understanding, they're very closely related. So concepts have definitions and examples. They're transferable, They're deepened through the grades, and they provide a focus or a conceptual lens. Concepts can be in relation with other concepts. And when we put them in relationship with other concepts, we create understandings that are also transferable. We got one more cusp to look at. That's the skills and procedures. What I've done here is listed all the skills and procedures from this organizing idea, and I highlighted the verbs. The verbs are those things that that sort of underpin the skill and procedures, and the other part is just the context. And so I think it's really important to separate out the two. because we'll want to make sure that kids are fairly competent in those things before we have them become independent in those. And I'll show you what I mean in a second. So if we were just to take away the content part, you'll see that happen on the next slide. We're going to take away some of the content part, and we're going to just focus on the verbs. What I've done there is just given you an idea of what those verbs mean. And then when you know what they mean, then you can decide what kind of activities you'll plan to do the rest of the outcome. So connect means kids being able to connect ideas. In other words, if they're concepts, can you relate those two concepts? What's the relationship between the Earth's rotation and the Earth's tilt of the axis and seasons, right? So I'm not going to go through all of them there, but they're there to help you. And I'm going to be going through them as a couple of them as we go through this organizing idea. But to fully understand what those verbs mean, really, I think helps to clarify. And you want to make sure that kids can also understand those words so they become independent in what they do. I just like to point out identify. It's in the center of the page there. Its use depends on how it's stated. It can mean to classify, for example, identify the images that are examples of mammals. You'll see that throughout some organizing ideas. Identify can mean to show something in a relationship. For example, identify, which is in this organizing idea, identify how observation of astronomical phenomena can determine agriculture and hunting practices. We're now looking at a relationship statement. Or it could be simply mean to recall. I mean, if there's the examples and facts are limited, it may be just a recall thing. For example, identify the stages of a plant's life cycle. It's just the knowledge that they're bringing up. So you have to look at that carefully. We can go on the next slide. I'll give you an example of taking one of those things. Let's take a look at discuss, for example. Discuss means to explore and examine a topic or an issue by either talking about it or providing a detailed analysis. And I threw this up there because quite often we think discuss is class discussion where people put up their hands in rows, and it can be a very, it should be a very active and I guess interactive activity. And there's all kinds of examples of discussions that you can use. So if we discuss observable features of lunar and solar eclipses and auroras, it could mean many of those things. And I don't have links to any of those, but those are all Googleable. And you can organize your discussion for that particular statement in a variety of ways. Keep on going. We know that represent means to communicate something in a different way. We can use writing, speaking, or some other form of expression to express what we mean. And so when it comes to represent observable features of lunar and solar eclipses and auroras, there are a multitude of ways that students can represent, including infographics. There's infographics and mind maps are linked because they may be ones that may be a little bit more unfamiliar to you. So those are all the ways that you can hit some of those skills and procedure statements. Just one thing with that you could take a look at that. Or if you're doing those non-linguistic representations, just keep in mind there's some things that are helpful that you want to make sure they don't focus as much on. Pretty is important, but that's not the only thing, right? There's some other things that we should consider, especially making sure that whatever they have, they can state why their representation expresses what it is, because that's what you want to see in it, is that they can relate what they've done to the knowledge and understanding that they're trying to convey, because their artwork or whatever they do may not be a good representation. So combining it with a verbal explanation is often a good thing to do to determine their understanding. And that brings us then to the phases of learning. So we know we've got knowledge, we've got understandings, and we've got certain skills. And what we want to do is go through the phases of learning to help students learn some of those key things at the surface level at the beginning, and then go into the deep component. And that's where they start making the connections and working with the understandings, and then transferring those ideas to different contexts and using the skills that were taught at the surface level with more independence. So the next slide shows a little bit more of a graphic associated with that. So the surface level, we're really developing those individual concepts and the skills. So just kids know how to represent. That was one of the skills that showed up there. Do kids know if you're going to have them make a representation? You might want to focus on, can they make a good diagram if that's what you want them to do? Well, what are the characteristics of a good diagram? Let's practice making some diagrams. They're good at that. Or if it's a comic strip, or what makes a good comic strip, if that's what you're going to do to represent. So it's probably a good idea to develop all those, because they're going to use those skills to demonstrate to themselves and to you and to others what they know and understand. So if they're not good at those skills, their full knowledge and understanding may not get through. So that's where you want to introduce and practice so that they're at least competent in those things. You'll notice that the concept shows up in a two-dimensional and three-dimensional form. Two-dimensional one would just be understanding the definition of a concept, of the concept, giving the definition and regurgitating it. That's one thing. We know concepts have definitions, but if they can provide examples, provide novel examples, distinguish between examples and non-examples, now they're getting a really good, solid understanding of that concept. And when they have this solid understanding of that concept, then we can put them into that process of connecting together those understandings. And then we explore those understandings that, for example, astronomical phenomena impact our life, if that's the understanding. Well, how is that true in this context? Is that true in this context? And that's where you get the different backgrounds and the different shapes under those connected concepts. Those are all just different contexts in which we examine it to deepen their understanding. And the transfer happens when you make a context that goes from something familiar to something more unfamiliar. So maybe we'll use our own lives as the familiar context, and maybe, who knows, the transfer move on to the Aztecs or the Mayans, something totally unfamiliar, depending on where you want to go with that. And of course, the skills, right? So we've got the skills at the surface level, they're getting competent at it, they become more independent at the skills of the deep, and then they become quite independent with it at the transfer. And that's how the phases work together. Really quickly then, there are some instructional approaches that do help out with each one. I'm not going to go through all these with you, but the concept attainment strategy is one that really helps with a lot of individual concepts. I have an example of concept attainment there for phenomena. You could take a look at it. One that's more direct, and the concept attainment strategy is very inductive. It's giving examples, non-examples, and having kids examine the examples and non-examples, and then come to a sort of conclusion as to what that item is in this case, phenomena. The state, elaborate, exemplify, illustrate can be used instead. It's more direct, where kids are given the definition and they can restate that definition in their own words, and then elaborate on it, provide examples, maybe provide an illustration, either a drawing of that to what that concept is, or a metaphor or something. So there's an example of how that might work. I'll do a spectrum shortly. I'll show you how that works. And then with the skills, I find one of the most effective things that I found is teaching skills directly. We're not going to go to that, but there's a link there. It's not fully completed, but it points out what is a discussion. What's included in discussion? What should we look for? And on that sheet that there's a link to, I link it to as well the communication part of the competencies that is also as part of the curriculum package, I guess. There's the communications piece that tells what kids need to be able to do, should be able to do at kindergarten to 3 for communicating, and then 4 to 6. And if you take a look at that, you could pull out some lists that may make a good checklist for you to help provide kids feedback on how they're doing with their communication in form of discussion. We'll go to the next slide. So still at the surface level, here's an example of a spectrum sort. So in this particular thing, it may be a good pretest even actually at the surface level to just lay those astronomical phenomena out there for them and just say, hey, which ones do you think impact your life the most? And which one impacts your life least? And then order the other ones into what they might do. And when you listen in on their discussion, it will give you a good example of, or a good indication of what they know, what they might know, what misconceptions they have, and so on. Or you could do this later on at the end and say, sort these. But then at the end of the day, you always want to do that communication piece. Well, why did you sort them the way you did, to get their reasons? Because when their reasons are really going to demonstrate to you their understanding. So a simple activity, but it can give you lots of information. Next slide. At the deep level, that's where we start. I said, now we've got those individual concepts understood. Now we start connecting them. Two good things we can use are concept mapping and asking conceptual questions. There's a whole lot of other there, but I've highlighted those two because those are the examples I'm going to share with you right now. Concept mapping, we can go to the next one, is just putting the ideas together in a relationship. So if we could take a look at that one skills and procedure statement once again, which said connect the direction of the Earth's tilt in relation to the sun, the length of the day and then the night. As an example of how they might connect them, what I've done is I've taken just little snippets, and I guess you could say some of them are concepts, some are not, just little details, and then ask the students, hey, well, arrange these ideas in a concept map that can meaningfully demonstrate that you understand what the relationship between the Earth's tilt to the sun, the length of day and night is to seasons. And a concept that may look like something on the next slide. It may look different, but we can, if you can click to that one, Chris. So it may look something like that. In this particular case, I use different colors for winter and summer. And the more concept maps you do with the kids, the more creative they'll get with them. This, if you've never done concept map with kids, this may be too big of an idea. You may just want some kind of a verbal explanation. But this is a really good way to get kids to show they understand some things. They put it together, and now when you say, well, explain this to me, you'll get a really strong sense of whether or not they are actually connecting those ideas together. Another good strategy to understand, to see if kids are making those conceptual connections, is to ask conceptual questions. And there's some examples there, and we can use them in any subject, not just science. I have some examples down there. It's always asking what the kind of relationship we build. So what effect does friction concept have on movement concept? That's a science one as well. Maybe language arts. What is the role of conflict in a story? What's the connection between those two? It's not just what is the conflict in the story. You're getting deeper now. You're connecting ideas together. And so we can do that with this organizing idea as well. And there's only one understanding, so it's always going back to the same example. Let's go on here. And the other understanding is that observations, interpretations, and astronomical phenomena can inform daily living. Well, let's turn that into a question. It's a tough one for the kids, and you may want to practice it or ask it in a different way, but I'll show you. So really, if you ask kids, well, what is the relationship between our observations of astronomical phenomena, our understanding or interpretation of it, and the way we live? Is there a connection between those? And if we go to the next slide then, we can see how we can take the skills and procedures and just tinker with them by asking a little conceptual question to take something that's at the surface level and move it to the deep. So if we take one of those organizing or skills and procedure statements, explore First Nations Métis and Inuit, you could read it there. Really what you're focusing on some specific knowledge to the Métis. You're identifying the way that their life is affected by some of the astronomical phenomena. And that's just giving examples. But if you ask them the question to go along with this, so you're going to explore, but if you're done your explanation, answer the question, well, what is the relationship between observations, interpretations, astronomical phenomena, and daily living? And why do you think that's connected? Justify using what you learned through your exploration and your own life experiences. And then choose a way to represent that understanding. So that moves it up to a whole different level, other than just saying, here's how the Métis and First Nations and Inuit, specifically just them, were impacted through astronomical phenomena, or impacted through astronomical phenomena. So it's just sometimes asking those questions that can take something up to the next level. And finally, there's the transfer level. It's basically the same that at the deep level, except you can do some bigger ones, such as the PBL activities, case studies, and just getting kids to get those different contexts and having them apply and test their understanding in a whole bunch of different situations. And that's, that's where you start getting that transfer, is when you can start giving them new context and they're working at it more independently. And one other thing, we have to decide when it's right to move from one phase of learning to the next. And that's where you do a lot of the formative assessments, right? And I have the three key words under formative assessments. We have to really focus on our observations, conversations, and the product. So kids are working and doing those activities that Chris is going to share with you. She's got a bunch of marvelous activities. I know she does. Then what are you watching? What are you seeing? Are the kids demonstrating an understanding of those concepts? Are they good at doing those skills that we're going to need to move on? If they do, then you go on to the deep and work with the broader understandings. And then as you're giving them those activities, you're still observing, you're having conversations, you're looking at the products they produce. So we're ready to go on to either a summative assessment or even more transfer activities, whichever your decision is at that time. To help you along the way with your observation conversations, we can just go to the next slide. There's some questions you can ask yourself at the different levels to make sure that you're getting a sense of where kids are at and ready to move on to the next phase of learning. So I know that I moved quickly, but Chris is going to share with you a lot of great resources and a lot of more activities. And as you're listening to them, I hope you can maybe find a place where they fit in that phase of learning. Away we go with it. So good luck with your organizing idea.
I just want to go back to where Ted was focusing on how they start making connections. Because one of the pieces that I really struggled with in putting even the grade 5s together is the lack of understanding that they would not have had from grade 4. This is new, right? This is completely new. And the whole science curriculum has been a spiral piece that goes along with it. And that's been a little bit of a growing curve for everybody. But on the same token, with space in itself, it's always been so condensed into one area. And now it's just been divided out that the students will have no background knowledge. So when you look at the conceptual connections that Ted is making suggestions on using here, I would say you absolutely need to come back to your slides from about 38 on, because once they get just that surface level information, they have to start making some connections between those. And you can't just dive into connections right off the bat because they just don't have the background knowledge. So we really need to spend the time going back on these. And I mean, it will look different, I would say, in a couple of years from now when we go through this and children are coming through and they've had some of that background knowledge. That's a very different scenario, but at the moment they don't. Oops, we don't need you on there. All right, so let's get into here. And so what we're looking at, the astronomical phenomena, I am going to bring back some of the pieces from grade 4 that we showed yesterday, just because really they're rather foundational. And I think the students are going to need that information before we try to move forward. So a little bit of a revisit. And again, it would depend on what the background knowledge of your students are and kind of where you're going to start with them. But we unpacked even just some terminology of what is the universe. And if you want to talk about astronomical phenomena, like that's way up there if you don't even know what the universe is defined to be. So this is where I feel like we need to bring a little bit of what we did before back into this conversation and start with them there. And just, it doesn't have to be long, but I do think there has to be some pieces. We also talked about what is the space objects. What do we talk about when we say space objects? So when a child goes outside at night and looks up at the sky, what do they see? What do they know? What are they familiar with? And so even just, this is a number of slides that we've already jumped into, but you know, just brainstorming with them, what would you see if you looked outside? You might see the moon, maybe you've seen some stars. And I would honestly tell you that I don't think that every child has seen a lightless sky. And I shared that yesterday, that my husband and I used to take high school students camping every year for 4 nights, and we would go to the mountains, wilderness camping. And that was the first ahas that we would get from the kids, is they would lay out in their sleeping bags at night and just look up at the sky and say, I've never seen that before. They have just never seen the volume of stars, the Milky Way, anything. because it's always been interrupted with other sort of the pollution of the sky, really. So just talking about what's the moon, what's the star, what is a star? That's what we talk about in grade 4. So they need to have a little bit of background. And then maybe what are their wonders? You know, how are you going to look at those stars? What tools could you use from home? You might not all have a telescope at home, but what do you have available that you could use? You could use binoculars, right? Where could I go to see stars if I can't see them? Well, we shared with them they can go to planetariums. We shared with them some virtual links yesterday that they could take the students to. And this is one of those ones that if you just want a bit of a good overview, this is called the virtual planetarium of the sun and the moon and the stars. But in that 27 minutes, they unpack a good component of what we talked about in grade 4. So it would give them a really good background, a starting point, and so much of what's talked about there even links into what you're going to talk about in grade 5. So there's lots of cross connections here. So when we talk about astronomical phenomena, those are big words for kids. And they may not even have a clue what that is. They don't even know what phenomena is, right? So, I mean, unpacking just that terminology, forget what it all connects to, is going to be important. So it's just observable events. Like if we can put it into a smaller context for them, an observable event that happens among objects in space. And in this particular case, we're talking about how those objects in space, the phenomena, actually affect what's happening in our daily lives in the world. Like, what are those pieces that influence what happens in our day-to-day routines? And if you want to start on a very simple level of an event, if you want to talk about a predictable pattern and a cycle, things that children might be able to acknowledge right off the bat is they know seasons. Seasons change. That's something they're familiar with. And by grade 5, they know their seasons. And they know that they come back and they routine, they change, and then they see the same kind of patterns over and over and again. And that we know that the length of the days change in our seasons. In wintertime, it's lots of darkness. In summertime, lots of sunshine. Why though? Why is that happening? And they should be able to explain that to us. We talked about calendars yesterday with the grade 4s. We talk about calendars today as well. But if I don't understand anything about the lunar cycles, that doesn't make a lot of sense to me. So that little piece is a grade 4 connection to the grade 5. When we talk about the moon phases, those all link together. So that's one of the first pieces that I kind of dived into for information. And that was, how does the Earth's tilt, how does that little picture that we have here affect so many things? In particular, let's start with seasons, because that's something that kids can relate to, and it is a little bit more familiar to them, some of the other terminology that we have. So this video that you have here, the Earth's rotation, sort of a crash course, they call it for kids, unpacks for you what the Earth's tilt does, the fact that the Earth revolves in itself around its own axis, and then is moving around the sun in addition to that, has those different effects to create our season. So it's not a big video, but it's packed with information, and it would be worth watching more than once. The other one that's over here seems very simplistic, 4 pictures to it, but the talk that happens in there talks about the things that are unpacked in your cusp. So when it talks about how does it affect, and the example that Ted gave you about, you have a picture, you have clothing. How does that temperature change, or how does that season affect maybe what we wear for clothes? In this case, it also talks about how does the season also affect what we look at from food harvest, right? In our climate where we live right now, we need that summer. We need that summer for growth, because we don't have a huge long growing season. So we need the summertime to get the growth. We see fall start coming in, and then we start talking about harvest, whether it's harvesting our garden, whether it's harvesting our fields, whatever the case may be. And then the other one down here, this is a nice little package, actually, and that's what I want to call it. This is an entire unit on the seasons put out by PBS and NASA. So it contains both the links for Google Classroom that you can share with the students, and it unpacks very sequentially how you can kind of go through not only understanding the Earth's tilt and the axis that it sits on, but how that's going to affect more than just the seasons around you. This is a lovely little piece that I would really suggest you spend a little bit of time just having a look at. Again, you're going to have to find a little bit of commonality as to where the students are at and find out what information they know. What do they understand? Question is, what's the relationship between the Earth's tilt and experiencing changes in the length of the day? That's a good start for them, just to do they even understand how that affected it? How does that relate to the seasons? Could you model your thinking, right? Can they represent it? If you want to talk about representing, I was thinking more of modeling. How does the Northern Hemisphere and Southern Hemisphere experience opposite seasons? Why is it when we have summer, down below us in Australia, they're having winter, right? And they experience Christmas in heat, and we experience Christmas in winter. Like, we couldn't even imagine it being in a summertime. So explain that again with modeling. I'm not saying they would do all of these, but perhaps they just need to consider some of the different approaches that make sense to them. Even just taking a flashlight and a basketball, a simple model of, if you took a flashlight and that's the sun, how could you model for me what happens to create day, night, seasons? And you could even have another person walking around, right? To get those different circumferences as they go around. Or relate the terms equinox and solstice. Those are the pieces that will come up in seasons all the time. But what does that mean? How does that reflect in the tilt of our Earth? So any one of these would give the child an opportunity to unpack some of the knowledge that we've just shared with them as just straight surface factual knowledge. How do I start making those connections between them? The moon's phases is another one. There's a cycle. A lot of students don't really pay attention to the moon. They know when it's really bright, but they don't necessarily know a lot about it. And that was a very jam-packed piece of the old grade 6 curriculum. And they did a lot of just sort of modeling it, drawing it out, talking about why it would happen, when would it happen, those types of things. So if we combine not only the information that's in here about the phases of the moon, we also combine that with the information that we even learned yesterday about the lunar calendar and how Indigenous culture look at how the calendar is interpreted. We're going to play this one just very quickly here. It starts to put things together. And so students have a way of linking some of the understandings. And I'm going to fast forward just a big piece of this here.
And Cepheus the king is represented by 5 stars. And those 5 stars, they sort of look like a house, outline of a house. There's a triangle on top and a rectangle on the bottom. So it forms like a silhouette of a house in the sky. So these 5 stars, the Cree people call Mackinac the turtle. And prior to the coming of the Europeans, Mackinac the turtle was basically our living calendar. Because when we saw that turtle, we were reminded of one complete cycle. We were told that if you look at a turtle shell, and this is evident of the snapping turtle and the painted turtle, the turtles I'm familiar with. I haven't been looking at the tortoises or any other kind of sea turtles or whatever, but these are the ones that I'm familiar with. So if you look at the shell of a snapping turtle or a painted turtle, on the inside of the turtle shell, there are 13 main sections. And we're told these 13 main sections are the 13 full moons of one complete cycle. And these full moons are separated by 28 days. So again, if you look at that turtle shell, on the outer edge of that turtle shell, there are 28 sections to separate the one full moon from the next. So when you looked at that calendar, you were immediately reminded of this turtle, and vice versa. The turtle reminded you of that calendar and of that cycle. Each one of these full moons coincided with something happened in the environment, depending on wherever you were. For the Cree people, that very first moon in the wintertime, when it was high winter, was called Kichipisim. And again, of course, that was around January various times in January. And then the following moon after that was Mikissiupisim. Mikissiupisim is the eagle moon, and that's when the eagles returned from down south. And the following moon after that was Niskapism. And Niskapism was the goose moon. That's when the geese came back. So you got January, February, March, and then April, that was Arigaspism. Arigaspism is the frog moon. That's when the frogs started coming out of sleeping. They're sleeping and started making all kinds of racket. So this.
So I'll stop it there, but that also helps students to understand when we talk about the lunar cycle and we say that the moon moves around and every 29 days we go through a new cycle. This is exactly it. And we talk about the lunar calendar versus 13 moons instead of 12 months. We understand how those connections come to be. And we also understand how First Nations then used those seasons and cycles to keep track of time. When the geese come back, we know that it's our third moon. And if you think about it, the geese are back right now and we just finished March, right? So our timing is very much where it should be. So again, those are pieces that we drew in both from grade 4 and put into grade 5 as well. So I also included the pieces on the lunar calendar so that when we talk about the different phases of the moon, students can also connect it to that as well as our solar calendar. How are they different? And how do the students see themselves in the daily lives? How is that different for them? Okay, let's go. Come on. There we go. So one of the points that's brought up in our cusps is talking about how did the astronomical phenomena that happens, where do First Nations take that? Well, we've seen a couple of them already. We also see that they use the different changes for ceremony. And often the running of the salmon would be one of those indicators. And they would have ceremony where they would be thankful that the salmon run has come. So again, there's all different ways, and it depends on what culture. And that's one of the things that Wilfred would always say. It depends on what culture and where you're sitting and who you want to listen to the story from, because that's going to change the perspective and the view that you have. So the same is true of our auroras. When we talk about the Northern Lights, it's a very different story if I'm talking from a Cree perspective than if I'm talking about an Inuit story. So in both of these stories that I've given you here, one of them is it's a cartoon, tells the story. This is exactly the same word, but it's live. And just a contrast. And I think for students to hear that and see, what are the auroras? Why do we have the Northern Lights? What happens for us to get those colorful places in the Northern Hemisphere? What happens in the Southern Hemisphere? So what are they seeing? So again, I've just given you some links in here, and then also from NASA, there's a great one there that gives you a lot of information for the students. I'm not a person who loves to impart. I love the students to do a little bit of research and come back and talk to me, or we move on and we do things. The following pages here are links to the connections between the skies and what the Indigenous culture has. I'm not going to run through any of those. Those are more for you to just sort of take and use as you see fit, and depending on which area you're going to take the students into and how you want to unpack those. Now, if we can get past them without them all turning on, that would be great. So again, you can talk about comparisons. You can talk about what we just watched about the turtle's back. We can talk about the lunar calendar. We can talk about the astronomical changes from the moon, the gravitational pulls from the sun. And we can talk about what are the relationships between the lunar calendar and the one that you just talked about with the elder, or the solar and the lunar. Same thing. We can talk about those. And those are also a carryover from yesterday. And some of the pieces to tie in the astronomical events and some of the phenomena that you're going to experience in that list of includes, everything that is in the includes, the auroras, the seasons, the day and night, all of those have been unpacked in a variety of those videos that we showed you. So it's a matter of where you're going to stop and ask them to start making some connections. You have more videos there than you would need. I tend to like to introduce a topic, but then come back with another video the following day, which is a different story, and have them make those connections between what we did the first day to the second day and what's new. What didn't we know before? And you'll find that too in the Sky Watchers and these particular links here, that you will find some of those connections, especially the daily aspects, like when are we going to have a comet? When do we have the auroras? What are they? There's very active ones here, the time measurement one. You'll find that those are very, very helpful. So this is where we're going to load their heads with a little bit of information first before we actually go back and start making some connections. There are 2 books that we found so far. We haven't found a lot, but I haven't started looking for a ton of them. The Night Sky is one. Wilfred Buck, Melissa Purcell is from Alberta, and she has done a lot of books for students. Both of them did a great job. This is a great link for grade 4 and grade 5. And then there's a second one that just sort of arrived yesterday called the Solar System. It's more of a grade 5 perspective of reading. And the connections in there are of the grade 5 topics that you're going to unpack, as well as the planets in grade 6. So this is another possible book, but we're just starting to look through resources to see what's available for you. And then just the links for the sources that we've used all the way through. So that gets you started. That's not by far the best list so far, but I do think that we need to give the kids a little bit of time to get caught up here and understand some of that terminology. When we get into grade 6, it's very much about the solar system, the planets, all of those pieces. And so that's almost a bit of a discrete piece that goes along with this, but having this knowledge is going to be so much more important. So there'll be some commonalities that we're going to carry through to grade 6 as well. So I hope that helps to give you a little bit of a start in the areas that we're going to be working in. What's going to happen in the next round of sessions, just so that you're aware, and again, you're welcome to come back. They're going to be open again, just as we did now. But what we're also going to be having is Janet Bell is going to join us, and she's going to be unpacking the computer science. And so she's already got one session posted through ERLC, so you can, it's already up and running, so you can have a look and register for that. But we want to get that incorporated. And as well, we're going to have Nicole Lamoureux. She's going to join us, and she's going to be looking at unpacking the scientific method. And then we'll try and incorporate each of those into the organizing ideas where it's appropriate. I mean, they're not always going to be a perfect fit. So this session of hour that we have right now will look quite different. We are not going to unpack all of that terminology that we did at the beginning. This is going to happen once in the introductory video that you're going to have access to if you decide to. And you will have the computing science video to watch in the introductory folder, and you're going to have one on the scientific method. So there's going to be 3 big opening videos for everyone to watch before you come to your very first session on an organizing idea. We are going to find that we're going to do exactly the same order. When we unpack the concepts, we found that there were enough linkages in the order that we had them. We're going to keep them the same. So we will start with living systems, and then we will follow that up with matter, and we will finish those before June 30th. So teachers will have choice if they wish to use those 2 as one of the 2 they want to start with in September, then they will have materials to do that with. And then we'll follow up again in September. Every 6 weeks, we'll do another organizing idea, and we should be wrapped up all of the organizing ideas before Christmas. So that gives you a half a year to kind of unpack that new curriculum. So it's not quite so rushed as it was this year. So that kind of is what's happening in a nutshell. Ted, anything I forgot?
No, I don't think so. No.
Okay, I'll just stop our recording here.